You're listening to Within Tolerance, a podcast for machinists by a machinist. I'm your host, Dylan Jackson of Proteum Machining, and this week I'm joined by CJ Abraham of Precision Product Development. Welcome, CJ.
Hi, Dylan. Thanks for having me.
Thanks for coming on. I know we've been trying to make this happen for a while, so I really appreciate you taking the time.
Yeah, it's been a long time coming, but it was finally time.
Yes. So for those who don't know you, what does PPD do? Where can they find you online? All that good stuff.
So Precision Product Development, I'm just a one-man shop in Southern California. I don't have a whole lot of company social media. I just go by cj.abraham on Instagram. And I post occasionally. I post a lot of stories too about what I'm doing. I can't necessarily post a lot of the parts that I do. This is just the nature of the work. But if people are interested, I could post more about the process and the tools that I use and things like that.
I think everyone would love that. I mean, you've got some pretty amazing machinery. Actually, let's get into that. What do you have? What kind of sector are you in? All that stuff.
Okay. I've got one Haas VF2SS. I got that in 2017. And I have two Williman Macadel 408 MTs. One was just installed about a month ago. I specialize in small milled components. Think like Swiss turning, but for not round things. And it's mostly high quantity stuff. So it's the challenge is in their small parts. They have tight tolerances, which everybody says that, but usually I'm going after plus or minus 1,000. There's a lot of plus or minus half 1,000, but over a run of say 5,000 parts.
Wow. Okay, so that's a typical size lot is 5,000.
I'll do anywhere from 10 pieces to around 5,000 is my biggest order that I'll do all at once.
Wow.
But I try to keep it high orders. The small orders I'll do as like preliminary prototype runs before they buy the full quantity.
Makes sense. I mean, those machines are kind of set up for just running nonstop.
Yeah. Or at least the way I've configured it is.
Right.
Yeah.
Right. Well, we've got questions about them. I want to definitely dive into that, but let's take it all the way back, get into your backstory. How did you get to where you are? I know some may know you from your time at Autodesk too. So, I kind of want to find out how you got to owning PPD and some gorgeous machinery and all that.
Yeah. So this is a long story. Hopefully I get it all in order. It all started when I was in high school, and I had an open slot my senior year of high school. I was pretty good at math. I took AP Calculus my junior year. I had an open slot senior year because I ran out of slots for math. But I saw CAD CAM, and I thought, that's interesting. I've never heard of that. And took the class. We had a lab full of computers with SolidWorks and Mastercam, which I think at the time was pretty unique for a high school. And we also had a machine shop, and there was a Haas TM1P there. So I really took a liking to that. I spent a lot of time in the shop learning the Haas control. At the time, I didn't realize how special it was to have that machine there too. Even today, I see a lot of first machines that people will be on will be a Tormach or any other sort of router. I don't want to say hobby level machine, but like consumer level machine as opposed to industrial level machine.
Especially at the high school level. I mean, lots of like Bantam tools, pocket NCs, things like that too.
Exactly. And so I didn't realize at the time how good I had it. Only in hindsight did I realize. But I really took a liking to that. And then kind of by happenstance, Al Watmo and Anthony Graves were in town and wanted to sponsor my high school with software, HSM
No
Works.
way.
Yes. So that's how I got to meet Al and Anthony. Is I was just this hotshot kid slinging stuff off a Haas, and I just wanted more. And they said, okay, well here is a license for HSM Works, not just HSM Express at the time. And I really just dove into that as much as I could. I had applied for Cal State Fullerton as a mechanical engineer. Or, I'm sorry, actually I applied as electrical engineer, but later declared mechanical. But it was just this like, I felt lucky that I found out very early on what I was going to be doing. This was it. So moved on from that. And at the time I was working for a connector company in Orange. and I was working in assembly. So I was stuffing pins and connectors, and that connector bit is important. This comes full circle. So I moved on from that connector company back in assembly, and I got my first job in a machine shop, and that company was KME CNC. So if you've heard of the the fifth axis tombstones,
Yeah, they have the wireless ones and things like that.
yeah. So I was employee number 4 at that business, I believe.
Oh, wow.
Very early on, it was like I machined the first tombstone that they sold as a product.
How cool.
It was very interesting. So they were in Orange. The first machine that I programmed as a job was a Kiwa KH45, I believe. It was a 400 millimeter pallet horizontal. So that was really going in the deep end first, right? It's okay. Well, here's your Haas TM1P. Demonstrate to somebody that I can program and I can make some designs, and they say, okay, well, here you go, make stuff. This machine, here you go.
Right. Yeah.
And this was before I knew how to do things like edit a post. I didn't have a whole lot of ideas about machine capabilities regarding like going from the Haas 6,000 RPM spindle. I forget how many horsepower, but to like a proper Cat 40 big plus taper spindle that could really do some damage. So luckily I never crashed that machine, but I broke plenty of tools. Yeah, because everyone has their first big crash, right?
Oh, yeah.
Luckily, I've never had. You know what? I'm just not gonna say anything. I don't want to jinx it.
That's a good idea. Yeah.
Yeah. Avoid that. But broken plenty of tools. Cut plenty of things I maybe shouldn't have cut, but haven't had any big issues. But yeah, that's I learned that. I was there for about a year. And then so KME CNC, they were making their own products, right? They weren't really a job shop. So I was doing a lot of the same thing, which is fine. But then I was kind of headhunted by a local job shop called Alva Manufacturing. And I went over there, and they had like the first UMC 750 in California or something like that. Okay.
Oh,
I think it was, they said it was machine number 3 that was sold. And so this is also before there was like the really good Haas posts from HSM Works and like the original UMC 750 post and things like that. This is before all of that, right? And by this time, I knew a little bit more about post editing. I learned plenty about 3+1 on the horizontal. Adding a fifth axis isn't that much of a step from that. It's just another tilt axis. But I wrote the post. I did all these things where I was making parts, and then Haas came in to do the training. And the sales rep there, Bill Bellina, from Machining Time Savers in Anaheim, I think he came in there and he was getting ready to give some instruction or something like that, or at least offer training. And he saw that I was making parts with the machine already, which was unheard of. It was like, this is the first time they had these machines out in the field, and they couldn't believe that somebody was actually already using it. And this was before it was the next end control too, right? This was the cold fire control.
Oh, wow.
So this is the original implementation of DWO and the first implementation of the MRZP calibration program. In fact, if you go on YouTube and search MRZP, you can see a video of me doing the MRZP calibration cycle from 2013.
No way.
Yeah. So that was an interesting experience. And this is also about the time that Autodesk acquired HSM Works. So you see where this is going.
Uh-huh.
So, I kept in touch with Al and Anthony. They knew what I was up to. They knew what I was doing. They knew I was still using HSM Works to do all these things. And of course, I was using HSM Works to program the UMC. And after Autodesk had acquired HSM Works, they needed to hire AEs in particular. And by this time, I had been a couple of years into my education at Cal State Fullerton. Al called me up, said, "Hey, do you want to work for Autodesk?" And besides the colorful language, he was like, "Heck yeah!" So that was like terrific. I couldn't have imagined anything else I'd rather be doing. And so the deal was They couldn't hire me full time because I was still a student. So they hired me as an intern. Uh, and there's lots of details that the more you hear, the more you ask, are you really an intern? Because I was basically a full-time intern with a travel budget, working from home, uh, and all these other things, right? And it was because I hadn't graduated yet.
Right.
But I
You're an
spent
intern and everything, or in name only, basically.
basically in name only. But I fulfilled all the other roles of application engineer, um, attending sales calls, going to sales, meeting face to face, doing demos, things like that. Joe Bailey was my manager at the time, and I have every person that I reported to at Autodesk has taught me so much, which is incredible. But Joe Bailey stands out as one of the people that just like he will forever be in my head, telling me things as I go about my life.
That's great. Well,
Yeah.
you were in a lot of like promotional videos too, and was that all at this time too? While you were technically an intern?
Yeah. This is also like the Don't Fear 5-axis video.
Okay,
I don't know if you saw that from like 2015.
Oh yeah.
Fun fact, that part, the bracket part, this video was not actually the video we planned to do that day, but we didn't have the machine available, but there was a UMC. So I'm like, you know what? We're just going to make a video. People are afraid of 3+2. So we're just going to show them it's not that bad. So, 15 minutes, came up with a part, did a program. That part has followed me for like the rest of my machining life. At IMTS, I went to the Lang booth, and that part was in the it was in the set for the vices and the robot.
Yeah, I saw it over there.
It's the weirdest thing. And I've seen it in all. I mean, we're getting off on a tangent here, but I've seen that part in all variations for different machines, used for different demos, but it all stemmed from that one Don't Fear 5-axis video.
That's great.
Yeah. But yeah, so did the applications engineer thing for a while as an intern. And then when I graduated, I was handed a contract and moved up to the Bay Area to work out of Pier 9 as a product manager for Fusion 360. And that was its own experience.
What does that actually mean for like those of us who are not in the know? Like we see all these titles, and they like we know you guys as like the Fusion people, but like I don't know the difference between like the manager or a product manager or any of these. They don't really mean anything, I think, to anybody outside of the business.
Yeah, well, there's also what titles mean to the industry, and then what titles mean to a company.
Right.
But
so for you, what did that mean as a product manager?
As a product manager, especially a product manager reporting to Al in that team, right? Because Al was the product manager and I was on the product management team.
Right.
But my role was to distill customer requirements, put myself into the shoes of the customer, which is not a hard thing to do considering my background, right, and determine how to build features that address the needs of our users. And I say our now, but now it's Autodesk's users, not my users anymore. But I still feel that way. And so that manifested as things like in Fusion, the NC programs feature, right? That browser object, we spent lots of time planning that, going through needs, what it was supposed to do. But I was ultimately the one that was at the time driving that forward.
Okay.
In terms of project planning, what it needed to do, and then that would be handed off to the developers, and they would go through the development cycles, and they would present it. We'd provide feedback until we felt it was ready for release.
Gotcha. I hated NC programs when they came out, and I resisted until it was forced on me, and now I absolutely love it. And I'm like, why did I waste so much time not using this and using the legacy post dialog box?
Yeah. So I appreciate that. And what that was born out of was, obviously, from the outside looking in, Al said this before on his interview, but the sausage factory. Mm-hmm. Did you follow the analogy there? Did that make sense?
Oh, okay. Yeah.
So it really is the sausage factory, right? You just see what comes out. But the purpose of NC programs was, you have the dialogue for posting, but every time you use the post dialogue, you might be doing something different. How do you save all of those settings? But that was born out of the need for somebody or even or organization where people are posting to different machines, but they need to be consistent and save the settings that they were using before. And so the hope there is that a lot of the new features that you're seeing introduced into a product like that were born from people having ideas that actually spent time in a machine shop having to deal with these issues. So I hope I left my mark on Fusion in that regard.
Yeah. Like I said, I love it now. Like it was one of those things where it seemed like it was going to add more time to my workflow to create NC programs. But it was only after I was forced to use it that I realized like, oh, I do repost programs quite a bit. And like right clicking and just hitting post is so much quicker than like making sure all my settings are right every single time.
Mm-hmm. Yeah.
And so I was like, oh, it's a no brainer now. But at the time I was like, why would I ever use this? I hate this. Like going back to the legacy dialogue, and then, yeah. So I appreciate it. Thank you.
Yeah, you're welcome. I hope, everything continues in that direction. I have a lot of hope for Fusion, even though I'm not there anymore. I didn't leave because I left because something else was growing faster than that.
Right.
For me. Right. But continuing along that line, I spent a lot of time as a product manager at Autodesk. And the reason you saw me doing other things was because at the time, the HSM Works team was very small, right? It was like a development team in Copenhagen, some other guys scattered around the world, me, Al, Anthony, and that was about it. And so we operated like a startup for quite a long time, which was like, what needs to be done? All right, we're just going to go do it. And that's why you saw me specifically in so many activities, is because we just didn't really have anybody else. And I wanted to do those things. And I mean, that worked out quite well. Some of our strongest relationships were born out of me just going somewhere and doing something. Joe uses the term smoke jumper. Like the firefighter is going out and putting fires. Yeah.
Okay.
And so I just remember, well, first of all, my travel budget and my travel habits, much bigger as an intern than they ever were when I was a full-time employee. But it would just be things like, hey, we've got this chance for a relationship with Haas at this thing. That was like the Selway relationship, for example. Selway had an open house and there was a couple of CAM systems in there that were programming various machines, and they stuck me in there and they're like, oh, you can go do the little 3-axis machine with your little Fusion, and we'll come back to you later and make sure everything is okay. And so I finished what I was doing with the 3-axis machine in about an hour. And there was, I think Al tells this story maybe a little bit differently to game of telephone, but I saw that machine and it wasn't running, and it seemed like it was at risk for not running in time for the demo day. So I offered to program it, and I did. And that actually displaced feature cam at the time.
Oh,
yeah. And
was this pre-acquisition?
This was pre-acquisition.
Oh boy.
So I think this was before it was known widely in the company, but it was probably something that was planned by then.
Okay.
But that's how we started the Selway relationship. It was like this little hotshot kid coming in, just wanted to program machines, and it worked. And if he can do it, surely anyone else can do it. And that was the basis for a lot of our relationships. So we just went in and did something, which is that's something I've observed enough to see how other relationships get formed in the business, right? Someone comes in, they talk up a lot. It's more like a sales relationship than it is a technical relationship.
Right. Oh yeah. A lot of this is just right place, right time kind of stuff. Like
exactly.
As cliche as that is, it really is like meeting the right person, saying the right thing at just the right point. You're like, oh yeah, I'm in for life. Like
exactly. I mean, that all ties back to like, this is all happening because I had a chance at a open slot in one of my high school classes, right? It's right. Like this, it's this crazy effect that sets you on a different trajectory. And so where are we in my timeline? I'm at Autodesk doing the product manager thing. 2017 rolls around and I'm like, man, I really want a machine. And how does this go? It's like everyone wants their own machine in their garage, right?
Of
Um,
course.
and
I have
so
machines in my shop and I still want one in my garage.
exactly. So, I had access to plenty of machines, but not in the way that you want to use a machine, if that makes any sense.
Mhm.
Um, it's always someone else. It's like borrowing someone else's car. It's like, it's not your car.
Right.
So I really wanted my own. But I was living in an apartment in East Bay, about as far east as you can go and still be considered Bay Area. And it just, I don't know, it was in my heart. So Angelo and I actually were getting together and just talking about it. And he said, you deserve your own shop. I was like, what do you mean? And he's like, I'm going to help you, build your shop. He had a machine shop. Angelo, right?
Yeah. Yeah. He's
Okay.
been on the podcast. Actually, it was a long time ago now, but
Yeah.
I'll have to have him back on.
Okay. Yeah. So Angelo, like a second father than me, he's like, I'm going to help you build your shop. I had one when I was your age, and you're going to do it too. And so he helped me get the VF2. He helped me find space. It basically, before you start a business, there's so much you just don't know. And it's just one of those things that it's unconscious ignorance, right? It's like, what are all the steps to even starting a business?
Oh, yeah.
How do you even get a bank account when you don't have the EIN number to make one? Like,
Right.
where do you even start?
Yeah. The unknown unknowns.
Yeah. And so, that was an experience in and of itself. It's just going through the process of starting one and doing everything yourself. It's just a whole new world. And so I got the VF2, got the space. I had a small flex space out in Livermore, and I just started doing stuff nights and weekends. And
so were you PPD at that point?
Yes, yeah. So the LLC was fully formed. I wanted everything to be legit in that respect, right?
Okay.
And so I started doing stuff nights and weekends, and I called that connector company I used to work for, and I said, "Hey, I've got a machine. I'd like to do work for you guys if you got it." They remembered me. They knew that I had attention to detail and those sorts of things. So they said, "Yeah, we'll send you some of our fixture work." And so remember that this is like 2 years before COVID started, right? And so really for me, at this point, I didn't expect to be building a business. I just wanted to be making parts on the side. And so that's what I was doing. I was making fixtures. I was making some of their tooling for some of the stuff that they do. They really liked the work I was doing. And it kept me busy, but not so busy that I couldn't hold a day job. But that was the goal. And they called me one day and said, "Hey, we really like the tools and products that you're sending us. I'm sorry, we like the tools and fixtures you're sending us. We want you to start machining our products."
Oh, wow.
Which this goes from like, I'm going to make 10 of these pieces, 5 of these pieces, to like they wanted 2,500 of a particular part number a month. Which that's like, and for anybody that's curious about what I do, if you search micro D connector, that gives you a really good idea of the type of work I'm doing. I'm not going to elaborate much further on that because of the applications that they're used in the kind of the industry. What's the term I'm looking for? There's a lot of trade secrets for the designs here, so
right.
I'll leave it at
I'm
that.
sure you've got a lot of NDAs and all that fun stuff.
Yeah. But it's small work that you can do plenty of on a table, like on a vacuum plate fixture, like I don't have one myself, but like a Pearson Pro Pallet system.
Mhm.
It's like the perfect thing for putting strips of material on and making lots of these parts out of them, which is the traditional way these parts are made. It's 3-axis machines, strips, you flip the strip, do lots of that stuff. And there was another customer that I was sort of doing this work for already, which was very small parts, like let's call it a 1/4-inch square. And I would load up a pallet full of strips and make 200 of them at a time. So I was familiar with the idea of doing long unattended runs. These are like 12-hour runs, just run them overnight.
Oh, wow.
And it was perfect because it was like I do my thing during the day for Autodesk. I go to my shop in the evening, get a palette ready to go, and it'll be done by the morning, right? Which it taught me a lot of things about running a machine unattended and what goes wrong.
Everything from
Everything goes
everybody
wrong.
I've talked to, everything.
Everything goes wrong. It's just a different animal. And the thing, especially for small parts, there's lots of problems particular to small parts, which is tool wear is an obvious problem, but how tools wear is less obvious. Which is you look at a part. A lot of the stuff I do is very geometrically simple. There's nothing complicated that I make. But the complication is doing it in high volume very consistently. The biggest problem is burrs. And what a burr is to you, I had to relearn because my customers are looking under microscopes for what they think might be a burr.
Ugh.
And it is, I was just watching a video earlier from Pearson, and he was talking about having fully completed parts off the machine, everything deburred, ready to go, which was like, I love that idea. But for me, I was just thinking about that, and man, if I looked at that part under a microscope, my customer would have a hernia.
Right. Yeah. Well, you're like, chamfer mills start leaving burrs. Like there's like
Yes.
little things that you don't really understand until you start looking at microscope level stuff. And you're like,
Yeah.
oh my goodness. Like everything just got so much harder.
To put this in perspective, I am making parts that have 4 thou plus or minus 1 chamfers, and I am deburring those chamfers.
Oof.
Yeah. So I've come up with some process for doing that off machine, and for bulk parts, right? It's I've managed that, but it still comes up, especially with new parts where it's like there's this one edge. It's always something where this is what I mean by high volume and small parts and getting very particular. It's like you will tune the program for hours for a particular edge, just one edge on this whole part. But that's what it takes.
Right.
I will happily spend 6 hours programming one 2D contour toolpath in Fusion because it saves me 24 hours sitting at a bench going through the parts one by one.
Yeah. At that volume too, like, it's one thing to deburr 5 parts or 10 parts, but like it becomes literally unmanageable at those kind of scales.
Yeah. Anyway, so long explanation for this is what I was up against, right? My customer said, we want you to go from making our fixtures to making our products, and this is how many we want. And at first I said no, which actually was very important for me to do. I mean, for all the young business people out there, people that are trying to start a business, know when to say no. Man, I think I had a lot of preparation coming up to that point, and so I felt comfortable doing it. But I could totally. I had other scenarios, so I did like fictive for a while too, and it was pretty easy to go like, oh yeah, I can do that, no problem. And then the job cost me, almost the entirety of the material cost ate up the entire cost of the job, right? So, at least those were quick lessons.
Yeah.
But so. At first I said no, and I continued making their fixtures, and they had called me again sometime later and said, look, we can't get any other vendors to do this right. We know you have the mind for it. What's it going to take? And so I said, well, with my VF2, I could probably do a couple hundred of these a month just because of the nature of like what I was doing, right? Had a day job, and just the sheer volume and doing these things on a machine like that is not, I should add that there was a complication with these parts where it wasn't just a 2-sided part anymore. It was a 4-sided part, which made it more difficult to do the traditional way these parts are made. So especially
I went on running it while you have a day job too. It's not like you can sit there and load pallets all day or something.
Yep. And so I went on a search. It was like, what's it going to take? I started off looking at the machines that one might go to first. It was like, okay, well, I've got this 3-axis machine. Can I get a Trinity robot and palletize them? Can I get a 4th axis horizontal and put them on tombstones. The problem with milling these parts is that when you do it that way, you always end up with one final hand flip, where even on a fourth axis, you could do 3 sides of the part, but that last operation, you got to hand load the strip, flipped over, and hope you get it right.
Right.
So I kind of felt that doing these on 3 fourth axis machines, I even looked at a Matsura LX 160,
Okay.
which it's the little 5-axis machine where you can fit 42 pallets on the whole machine, and it's like in the space of a VF2 basically.
Yeah, they're super cool. Linear motors, all that fun stuff.
And I looked at all of these machines and I was like, man, this isn't the right way to do it, because I don't want to touch any parts. That was actually one of the goals I had early on, is how would I go from material to finished part without touching it? And that takes you right into bar feeding. So I looked at machines that could bar feed these parts, and that was like Swiss machines, so Citizen, Tornos. I looked at Eurotech because that's what Sellaway was selling. I looked at all these machines and it was like, yeah, all these could do it. Like I can bar feed it, I can grab it with the sub spindle and like all these other things. But it was like, there was something that wasn't right. I don't know. I still don't know how to put the words to it, but there was something about every one of these machines that I looked at where it's like it checked all of the boxes, but something still didn't set right.
Right. It was like an inelegant solution.
It was the inelegant solution, especially because lathes with live tools have a limit on those live tool gears and such, right? And then there's lifespans for all the live tools when you're going with speeders and things like that. And all these parts are milled. I go down to like 20 thou tools, for example. Like all my tools are under 1/8 of an inch.
Right.
And so it was like, man, it can do it, but it just doesn't make sense. And the next machine that I had looked at was the Mazak Integrex series. So it was like, oh, well, okay, there are these machines that can be bar fed. It's the Mazak Integrex, Mori NTX, the NTMX, a lot of these other machines they're basically the B-axis military machines of the world, right?
Right.
And what was wrong with these ones, they were still sub spindle machines. And so no matter what I was not making round parts. Everything I do is square. So would have to machine either like some odd 2-jaw chuck arrangement or like the emergency collets or something I could grab the square part with. So that was kind of hard to justify. And also all these machines are big. They still make bigger chips than the parts I'm intending to make.
Right. Clearances would have been a nightmare on an Integrex or something.
Exactly. And so even in addition to that, the thing that's always in the back, what's in the background for all these machines is, how do I get the finished parts out of the machine? Because even on this Mazak that I looked at, the first thing I saw was like, okay, well, there's the part chute, but the slits in the part chute are bigger than the parts. So they'll still fall down into the, and so I'm trying to paint a picture of how small the parts I'm making are, right? And so it was like, man, none of these make sense. I even went as far as to get like a proposal on that Mazak, because what I found out on the Mazak was that the I-150 can be optioned with the part handling vise. They have that vise system on that machine. And it's like, oh, this is really close. Like that was like the closest machine I had found before Williman and these series of machines. So we'll get to that. But it was like, oh man, if that machine just came in a smaller everything, that would be the perfect machine. And okay, so now let's get into the Williman. I had heard of Williman before, but not in this context. So I wasn't thinking about them yet. It was like probably a year before I started the search that I heard from a buddy in Northern California that he got this crazy machine. It was like one of a kind, and no one ever uses these machines. And it was a Williman 518. Okay. And it's kind of the bigger. I wouldn't say it's a rare machine for Williman. I mean, when you hear Williman in the context of the Instagram machinist community now, you basically only hear the 408 because of me, Grimsmo, John, and those guys, right?
Right.
John Saunders, I mean. Mm-hmm. And so that was the first time I heard of Willman, is this 518. He got a crazy deal. He bought it from like a medical company, auction for 30 grand. Machine was in perfect condition. 30 grand should raise some eyebrows, right?
Yeah.
And so he bought the machine, and I guess the auction company didn't know what they had. He was opening boxes, and it's just like brand new boxes with new tools. He's like, man, it's like Christmas over here. What's going on?
Wow.
And he bought the machine because he's like, it was a deal. I lowballed it. They went for it. I'll find a reason to use it. And if I can't find a reason to use it, I'll sell it. Which was his thinking. And so he sold it for something like 300 grand or something. Which is just like, that was my first, that was the first time I ever heard of Williman. And so I didn't understand the context or what the machine was. He had asked me to write a post for it, but I never got to doing it because he never used it. Right. And so the next time I heard of Williman was at Fusion Academy, because at least this is how I remember in my head. Someone was there that I had met. I believe it was Marcus, that I told about this application, and he looked at it and he's like, oh yeah, sure. And I looked at the machine. It was like, oh man, this is exactly what I'm looking for. It's the smaller Mazak I-150 that I was looking for. This is nuts. And I couldn't believe, man, it was just like everything that I've been looking for over the past year, doing a search for was like what it was going to take, right? Because my customer was still calling me like, hey, we still want you to do these parts. And I was like, I haven't found the right way to do it yet.
That's
the
crazy.
408
Like,
MT,
good for you that you like clearly impressed them enough that they're willing to, bug you for over a year to have you do this.
Well, I had done a prototype for them. Like I had done 2 parts that, just demonstrating like, look, if I would do it this way, this is how it would be done, but I don't have the machine to do it this way yet. But the Williman 408 MT, they're usually found in medical device companies, jewelry companies, things like that. In their standard configuration, it is basically a B-axis military machine, but really they're called bar-fed 5-axis machines because they're primarily mills. In their standard configuration, the 408 MT comes with an 18-inch bar pusher, has an A-axis spindle, has the milling spindle, and a part handling vise. And that part handling vise is on a U-axis, and it flips up and down 90 degrees so that you can come up, grab the part, mill something off. You can machine the backside when the vise is down at 90 degrees, which is how you get a 6-sided 3+2 part, right? So you can make a cube from bar finished for as many times as you want. And a lot of my parts are roughly rectangular, which it was the ideal machine, especially for small part machining. This particular machine can be optional with a 30 or 42,000 RPM spindle, HSK 40E, which is perfect for small tools, right? Really, it's a pretty small work envelope. I think it's, let's say it's like 100 millimeters cube is the work envelope. But really the max part I would ever make fits in a 1 3/8 bar and about maybe 2 inches long. Right. So let's call it 1.5 inch cube is the max I would ever go, really.
Right. So for anybody who went to IMTS, the little vise body that they made is kind of representative of what you would call your biggest part.
Yeah. And even that would be like the extents of, yeah, definitely. Now they've got other configurations of machines that could do bigger parts and things like that. But this was like, oh man, this is the one. Also, tool changes super quick. It's like 3 seconds chip to chip, if that, because it only moves 2 inches to go up to the tool change position. Really small tools changes pretty quick. Short tool arm, and even the tool checking really quick. My machine, my first one, has the TS27 for it's a contact probe, but it also has a flicker, and so I have a video on my Instagram. But the part or the tool will come up to the tool check position. It'll flick the tool to see if it's still there, and then go into do a tool change. My newer 408 MT has a laser in the tool carousel, so it doesn't even have to flick the tool. It'll do a tool change. It'll check the tool inside the tool carousel before the next tool makes it to the part.
Oh, cool.
So it's a 0 lost time tool check. which is
That's
really important because a lot of the stuff that I do, this is the caveat to the machine configuration that I've chosen, is that it's one piece flow, maybe two piece if it like fits correctly, right? So I'm doing all the tool changes for every part. My first machine is going to hit 1 million tool changes this year.
oh, that's nuts.
Yeah. And so there's a lot of man, this I feel like I'm still going off into the weeds of my timeline here. I felt like I was going to get this wrong, but this particular machine I heard about in 2019. It was a demo machine that was at IMTS 2018, and it was the one with the UR robot attached to the side. The reason it had a UR robot was because they were advertising this as a small footprint bar fed machine. And so instead of loading, or I'm sorry, they were loading 18-inch bars into their bar pusher with the robot instead of having a bar feeder.
And I didn't realize, I talked to Jim, the apps guy from Willamette at IMTS, and I didn't realize that that's a Willamette USA thing. Like I didn't realize that that's not like a global thing. That's something that they're doing and like building the stands and all of that.
Yep. Yeah. That's, as far as I know, that's just the US thing, but it works great. Now, when I looked at that, I knew how many parts I was going to be making, what I wanted to do with it, how I wanted to buy material and things like that. Because I buy all material in 6-foot bars. So I'll contact my material supplier. I'll say, hey, I want this many bars, chop to 6 foot, deliver them like that, right? So I wanted a 6-foot bar feeder, which in terms of machine price, adding the bar feeder is not insignificant, but also like not that big a deal considering the overall price of the machine.
Right. No brainer at that point.
Exactly. And I was focused on reliability. It's like, okay, this 18-inch bar pusher is going to load X number of bars overnight. Is it actually going to load them reliably that many times overnight? And I had a lot of back and forth with people about that. And it was like, yeah, the UR robots are pretty consistent, but no one was really confident they were that consistent. So I opted for the bar feeder, but I kept the UR robot. And so what I do there is I still load everything with 6-foot bars, but I'll use the robot for unloading of parts that need that kind of attention. Normally with the 408MT, there's a part basket on the side of the machine and a chute for parts to fall down. Mm-hmm. So you finish the part in the vise goes down, the vise opens, and the part falls down the chute into an oil-filled basket so they don't plink into each other. But sometimes I've made a couple of parts big enough that they don't fit reliably down the chute, or there's enough material left on the part that they're heavy and still will smack into each other and leave dents or something like that. And so for those, I will unload it with the robot. And in that regard, it's been required. I would not have been able to make those parts otherwise without the robot, or I would have had to come up with something far more clever. So I have one machine that has the robot. The other one, I did not get the robot, just has the bar feeder, because for the parts that need the robot, it's not that many. So I'll just continue doing it on that machine.
Okay. Yeah. And it was your first machine or your second machine that had the robot?
It was the first machine.
Oh, okay.
Yeah. Because that one was the demo machine that was like ready to go in their demo room in Indiana. Nice. And so I said, I want that one because it's right there and it won't take a year to build.
Right.
And they had a demo machine discount on it and some other things too, right? So it made sense to get that one. Mind you, this is still all going on while I'm still chugging away at my full-time gig at Autodesk. So I was making it work. And this is also about the time when, I'm sorry, what I should say is I presented this to my customer and I gave them the whole business plan on why this is the right machine, why everything else wasn't the right machine, productivity, KPIs and things like that. And they said, okay, what's going to take? What do we need to do? So I have an arrangement with my customer that makes sure that the machine is paid for and that everything works right.
Nice.
So that worked. And about this time is when COVID started. Right. So I had to rewind a little bit because COVID started before we decided that we were going to get this machine. And I had moved back down to SoCal. So I took my machine out of the shop in Livermore. I I'm living in the home that I grew up in, right? So I'm renting from my parents while I figure
Nice.
out how to navigate this crazy real estate market in Southern California.
Oh yeah.
My shop is 5 minutes away, which is really important for running things overnight and unattended. So that was kind of it. It's like I got my VF2 here. I got space for this machine. They said, let's do it. So we did. And this is about the time when it's like, okay, is this really a side gig anymore? So, and the way I explain it to people is like the first one was like a miracle. The second one was like getting struck by lightning. Um, so, it really it is hard to describe how good these machines are. With every new machine, there's little gremlins to figure out, or something doesn't work right, or whatever. But with this machine, and actually this machine in particular worked right off the bat because it was a demo machine already working, right? But it was like, okay, well, let's go ahead and make the first parts off of this thing. And it was like, everything came out right. Okay, well, let's make more, and let's make more. And it was just like, okay, well, let's make 2,500 parts now. And it kept going. And here's what I learned. As much as I said things about like deburring comes up and you got to really dial in programs and all these things, what I learned is that through clever use of tooling between roughing and finishing tools and where you're doing things, I don't experience finishing tool wear pretty much at all. I've looked at, I do a lot of tracking of probe data, like the probing results. And I wrote a little script to plot tool wear versus the deviation on a feature from the Renaissance Inspection Plus macros.
Oh yeah, you sent me that. It was disheartening how cool, like how good it was compared to anything I've ever seen.
And I'm currently running a job in titanium. It's 5,000 pieces. I have to go back and look at the most recent data, but over a 5,000 piece run, the probe says that it's somewhere between plus or minus 5 microns.
That's nuts.
And the tool wear has only been a couple of microns, maybe. And it's, I also, I plan very carefully how roughing and finishing tools are used. And sometimes I'll do things like one tool per feature and things like that. Also, I think that coolant selection helps a lot. In one machine, I'm running straight oil. The other machine, I'm running Qualichem 290, which is basically an oil replacement.
Oh, really?
Yeah.
I'm surprised you're not running straight oil on both.
The fire risk.
Oh, that makes sense.
Yeah.
Yep.
So that second machine is basically dedicated to titanium.
That's fair.
And so I'm not going to run titanium unattended 24/7 for 4 weeks at a time. Like I turned off the machine for IMTS, but the night I got back from IMTS, I turned that machine back on and it hasn't been off since.
That's awesome.
And I don't have like my run times. Yeah, I have a personal goal. I want to see 168 on the runtime at some point, but I don't typically do that because I'll run it for 24 hours. I want to check it every 24 hours. I want to come in and see it. I want to look at the parts. I want to look at the coolant lines. I want to listen to it. I want to hear everything. I want to see everything, right? Because I don't know what's going to go wrong. And I think that's the other reason I haven't had problems is because I'm always looking out for these things. Just from my previous experience with the VF2 making parts all night.
Right.
So I think that's a piece of advice I would give to people that are trying to focus on doing long production runs. A lot of people probably just have this experience already, but if you're new to it, you really got to know your machine. Like you have to understand it inside and out and know all of its noises and how fast it typically does things, what it smells like. I'm not kidding, right? Like I'll be in my shop and I've got other neighbors that are doing other things. Like I've got a powder coater neighbor and some other guys, right? I'll hear something. I'll be like, what was that? Or I'll smell something and be like, is something burning?
I do the same thing. I've got a mechanic to one side and like finishers and wood workers on the other side. And, they'll spark up a saw or something and freak me out because my parts that were running perfectly and sounding good all of a sudden sound like garbage.
Yeah. And so I don't have kids, but in some ways, I feel like this is what it's like. Because everything concerns you.
Right.
And you sleep with one eye open.
Maybe we should talk about the software you use then to make this all happen, because I know you're kind of the poster child for a few of the softwares you use, and I imagine that having things that help you manage, runs of this size and keeping data and all of that are really important to you.
Mm-hmm. Yeah, so I'm using Fusion 360 to program, which is kind of natural, but a lot of people, man, how do I put this? It's like there's still this unprofessional perception of what Fusion 360 is,
Right.
which kills me inside. Because I talk to customers of Williman, they'll be like, okay, well, I got to program this, got to program that. And it's like, well, I do all these things in Fusion. It can do all these things. I wrote the post, which helps a lot.
Yeah.
But I compare a lot of these things to a Rubik's Cube. If you don't know how to solve a Rubik's Cube, it looks very complex and even intimidating. But solving a Rubik's Cube is just a arrangement of simple ideas. It's just a consecutive application of simple ideas.
Mhm.
The Williman in this regard and programming with Fusion is no different. It is a series of simple ideas put together to look like something bigger than it really is.
Okay.
If I could break it down, it's just a sideways 5-axis machine, and there is a sub spindle that flips up and down. From there, it's just like, okay, well, how do you position it? How do you open it? Things like that. Fusion has the sub spindle grab and return operations, which serve as perfect platforms for controlling the vise, because all those operations do is say, go here, go there. And it has a couple of other commands that's like open, close, but those are all implicit in the post based on some of the selections that you make. But all the commands are there. So in my humble opinion, Fusion 360 is by far the easiest way to program a Williman 408MT. Possibly even some of their other machines, like the 508 that has the 3-station part handling system with the vise, the tailstock, and the sub spindle.
Mm-hmm.
Writing a post, I don't have that machine, so obviously I haven't written a post for it. But it's a logical progression where instead of saying you're controlling the device, you just declare which device you're controlling, and then that operation can control it respectively. And then from there, it's just a issue of, can you actually program in Fusion what you want? It's like programming the toolpaths is different from the part handling.
Mm-hmm.
So all the part handling is basically covered. So if the toolpaths cover what the part needs in terms of turning toolpaths, 2-axis, 3-axis, 5-axis, all those sorts of things, if Fusion can program the part, I think here's the challenge that I'll put to anybody. You can write any Fusion post for any single channel machine, no problem.
Okay.
Right? A dual channel machine, there's just some challenges with. You need a little bit of clever post editing, but I think any single channel machine you could write a Fusion post for, no problem. So that's what I use for programming. When it comes to ITAR related components, I have to fall back to HSMWorks.
Okay.
And so when that need arises, SolidWorks and HSMWorks is my fallback.
Right.
I mean,
but same post and all that.
Same post. Yeah, it's the same everything, right? Which is kind of the beauty of that. I can invest a lot of time into that one post and it serves my needs. Another software of note that I use is ProShop ERP. Fusion runs my machines, but ProShop runs my business.
Yeah. I mean, it seems like it could be incredibly powerful, especially for a shop your size where you're relying on it to kind of keep everything straight as far as work orders and quantities and all of that.
Yes. ProShop makes me look like a far bigger business than I actually am. Until someone from quality starts looking through the packet of documents and be like, this is all signed by the same guy. This is weird. But yeah, so, and I've written a couple of things into the post. So ProShop can parse G code to look for tool information. And so when you load all that information into ProShop, it'll start telling you really nifty things like what tools can you take out of a machine that aren't relevant to any active work order, so you know what tool holders you can replace with something else.
Oh, that's cool.
Yeah,
that's really handy.
It is super handy. I remember early on, I was like taking notes, like, okay, I need all these tools, write down the tool numbers, go over to the machine. It's like, okay, are any of these matched up? No. Okay, so I can take these tools out and reload them and stuff like that. But like that took a while, and it was all cross-referencing the next active job and things like that. But with ProShop, when it's all loaded in, it just tells me like, yeah, take out these tools. You need to load these tools. You're good to go, which is awesome. I mean, I could talk for hours about ProShop and every little facet that it does, but this isn't the platform for that. But if you have any questions about that, happy to answer them.
Well, and I know Paul we're in talks to have him come back on the show too. So I'm sure I'll get ProShop overload next time he's on.
Okay. Yeah. At IMTS, I had the chance, or I was invited to spend a couple hours in their booth talking to people, which is a great experience because some people actually came to seek me out specifically because I'm known as being a one-man shop with ProShop. And it's like, what's it like having an ERP system being one man? It's like, there is no other way I could function. I should say my customers would otherwise require that I be AS certified or ISO certified. But because I've demonstrated with ProShop that I am compliant in all these regards, they're okay with what I've got going on.
Oh, that's excellent. Okay.
They have said that ProShop is better than what they've got. So they know that I've got all the records that I need. They're satisfied with everything I send them. So they've wrapped me under their umbrella.
Oh, awesome. Do you ever find it cumbersome? Because I know that, and a lot of people that I talk to, taking on an ERP just seems like extra steps to make parts.
It is, but in the same way that NC programs look like a daunting task in the beginning, but has given you returns, ERP is the same way.
Okay.
There are upfront steps that you have to perform, but the gains that you get downstream from the increased efficiency just outweighs all of the other inputs, right? Because using the ERP system starts from the estimate. And when I put all the information in the estimate, it flows down all the way to the packing slip when it leaves.
Okay.
And so there's a lot of stuff that I only have to put in once. And there's just so much that it saves so much time. For example, what's a good example of this? Material certs. That's a good example. This one's simple, right? So in ProShop with a vendor PO, I will submit a purchase order for material to my vendor. When that vendor sends me back the material, the cert comes with it. Sometimes I send it digitally, which I prefer. I'll attach the PDF of that cert to the vendor PO that is in ProShop. So it's part of that record, right? Now, when I go into a work order and I consume that material, the material cert is automatically included in the document package. So when I go to ship something, there's one button that is like create document package, and it pulls down everything it needs. So the CFC, the AS9102, if I'm doing a first article, all the material certs, approved drawing and all those things. I get all that stuff just by clicking once and it prints it, or I can send a PDF off to my customer. And it's just one click. Where I've heard so many stories about like, where's the material cert? How do I do all these things? It's like, I've never worried about documentation simply because that information is just there and it's instant when I need to access it.
Okay.
As the person doing every click in the ERP, it's very obvious to me where the efficiencies are gained. To a larger company where maybe it's more work for one person, it's not as obvious to them how it saves them time downstream.
Right. Well, and that's especially why I wanted to ask you about it for sure. Because I know we've right now, a majority of our customers don't require that, but I can definitely see the push kind of globally towards needing that kind of stuff. And so ProShop's definitely been on my mind on and off for a couple of years now. Yeah.
Man, it's hard to understate how important ProShop has been to my success. And like I said, it makes me seem like a bigger company than I am because it makes me that efficient. It's like buying employees. It's, the the subscription price of ProShop is well worth the price of not having to just hire somebody to do data entry, right?
Right.
And the other thing about ProShop is I don't know how this is with other ERP systems, but for ProShop, it was built first as a quality compliance system. And so everything you do in ProShop is geared towards quality compliance. So there's not like additional work that you have to do in order to be compliant. Just through the use of ProShop and using it properly, getting AS or ISO certifications like flipping a switch.
Right. Well, and I don't know if they still do it, but they had that like quality policy in a box thing that you could buy.
Yeah, they call it Flying Start. Yeah.
Yeah. Yeah, that's what it was. Yeah. So, I mean, yeah, it sounds like, if you're planning on going AS or ISO, that would be like the easiest, like the easy button to go that way for sure.
Yeah. Yeah. I would say if you have to fight your ERP system to be quality compliant, you're doing something very, very wrong. But yeah, just the gains that I get from using ProShop in particular. And, I sound like I'm really fluffing ProShop here, but it truly has been important for me to have an ERP system that is effective as ProShop, at least.
For sure. And I would be remiss if I did not give our friend Pete his plug as well. You were like cycle time world champion on Chatter. Every time you post, you're like 100%. So how has that been for you being able to monitor all that stuff through Chatter?
Okay. So this is another tool that I cannot, I've said this to Pete directly, I cannot function without Chatter. And what it gives me is even if I'm just in the other room, I don't know what the machine's doing, right? And as long as everything's running, everything's fine, right? I don't actually care. I just want to know if something goes wrong. Did a tool break? Was there some alarm? I'm curious about probing results, but that's all closed loop, so I don't really worry about it. But like, if I just want to pulse on what's going on, how do I check that? Or how do I get a notification? I've wanted so badly for just like text messages to go to my phone. Hey, a tool's broken. Haas did this a while ago with their Haas Connect, which I had early experience getting text messages, or at least getting it wasn't text, it was push notifications from the Haas app, which, I would get a broken tool every once in a while at 11 o'clock PM, and that's a good time to go fix it. Or I would get a notification at 3 a.m. and be like, God damn it. And then I have to go in, and I know I'd have to wake up early just to go get that arranged and maybe have it continue through the rest of the program. But, I will leave my machine for 12 hours or more unattended at a time. And so how do you know? I even have a couple of Wise cams just so I can look at it. Like, is there any coolant on the floor? No. Awesome. I've never had that problem, thankfully.
Oh, lucky.
So I really enjoy getting those push notifications from the Haas Connect app where I could see, there's a tool broken, or the machine's still running. So Chatter in that regard replaced and actually really enhanced everything that the Haas Connect app could do. On both the Willemins, I have FANUC controllers. So through Focus, I can get the machine monitoring data. And it's really nice to I'll open Chatter right now, and I'll take a quick look here because I just have the one machine running right now. The other one's in a warm-up cycle. My active today is 94%. And
well, thank you for taking the 6% hit to come on the podcast. I appreciate it.
Oh, well worth it. You're welcome. And I've got 7 hours on the other machine until I go in there and just check on it and then run it for another 24.
That's awesome.
So I'm actually, 7 hours from now is pretty late. So I'll go in there and I'll re-up it before I go home for the night, kind of thing.
Yeah.
But it's nice to, first of all, look at a dashboard. So I'm just looking at it on my browser right now. It's there. I can just see it. I can look at it on my phone. So when I'm out at dinner, or I'm just chilling, or I wake up at 2 a.m. and I'm like, what's going on? I can look at it and see a bunch of green and just go, yep, okay, I can go back to sleep. Everything's fine. And then the other advantage is that I get text messages for alarms. Mm-hmm. So I'm going to look at what's my most recent alarm from Chatter. I can pull that up. My most recent alarm from Chatter was at 3:40 for Williman number 1, parts number is reached. Right? So that's why that machine's idle right now, because it's waiting for its next job, right? So a couple before that. So for example, yesterday, I had a probe open alarm. So there was a chip on one of the parts when it was getting probed. So I got the alarm and I got the text message and I knew, okay, I just got to go down to the shop real quick, restart that program. And it was good to go after that, right? But getting those text message alerts specifically of what the alarm is also kind of determines the haste at which I go back to the shop.
Right. Oh, yeah. Yeah, for sure.
Tool broken alarm, no big deal. Probe open alarm, okay, that's fine. No air pressure to both machines. That sounds like a problem. That sounds like something went wrong.
Exactly. Yeah.
It sounds like something popped. I have never had that alarm, to be clear.
The peace of mind is definitely what I like about it most too. Like you said, I'll be able to, like, we had parts for a couple of weeks that were running like about 2-hour cycles, and I could just set one up and I knew there was tool breakage for everything that might break, and I'd go to lunch, and like you said, about halfway through lunch, I'd be like, yep, still green. Cool. Okay.
Yeah.
Not
have you ever
about
slept through a machine run?
No, I haven't. We usually don't have anything that runs anywhere near long enough for that.
Okay. Yeah. I run almost every night while I'm sleeping.
That's awesome. That is really cool.
It sounds, it's like one of those grass is greener things. Because you can make bad parts in a hurry too.
Oh, I bet. Yeah. And I'm sure bar stock is not cheap when it's titanium or stainless or any of that.
I would say it's a surprisingly manageable amount.
That's good.
Yeah, especially for small parts. Most of the cost is in the machine time. And so like if I lose half a day's worth of material, that doesn't sting. It's the time that matters.
Oh, gotcha. Well, actually, we're bringing up some good stuff from some of the questions we had. So let's jump into those. Chris Sabatini asked, how do you like working for yourself, and what's been the biggest challenge so far?
Working for myself, many of the people that are close to me that have worked with me before probably know or will laugh if they hear this answer, but I hold myself to a particularly high standard, and I have a hard time deviating from that. But that works well for me working by myself in a machine shop, because then I have no one to blame but myself.
Mm-hmm.
And so it's like I can really truly focus on what I need to do at all times, anytime. Now, working by myself, I don't have the benefit of having more hands, right? And I do run into that where it's like, man, sometimes I just wish I had somebody that I could say, you need to take these 1,000 parts where I messed up and deburr this edge on every one. Because I do that plenty. Unfortunately, it happens. It's just kind of the part of part development too, right? From time to time, I do find something where it's like, man, this one edge, if I just would have spent the extra 30 minutes to program this one edge in the best way possible, I would have saved myself 8 hours of deburring or something, where then I could be doing something else, right? That's the challenge of being one person, is that you're one person.
Definitely.
But my hours, I mean, I never count my hours is in terms of how much I work, but I wake up, I go to the shop, I work until I feel like it's time for me to stop working, and I go home and sleep and repeat. My work habits work better this way because I like to, how do I put this? It's not like I have attention deficit, but I enjoy being able to do what I need to do exactly when I need to do it and not have to worry about other things. And so, but with that, it's like I'll work a 12-hour day and not realize it. Longer sometimes.
Right.
So I would sum it up that way. As I would say, working by myself is how I feel I'm most effective, but my resources are limited. And so I will have to eventually I will have to grow this business bigger than myself. It's inevitable. I have to do it. I have to cross that bridge. What that looks like, I don't know for the time being, because right now it's manageable.
Good for you. That's awesome. Let's see. Josh Hacko, NH Micro asked, well, see, you already answered part of this. What is the usual volume of parts you make? And if it's low, or when you do low runs, how do you amortize the setup time and tooling associated with a mill turn? Are there any big time savers or investments in processes that you've made to streamline the job shop workflow?
Okay, I like this question. So I do low volume runs and high volume runs. I prefer to do the high volume runs because it takes me, for example, I take orders that are 10 to 25 pieces. I try to limit those. It takes me the same amount of time to make 10, 25 pieces as it does 200 pieces. Like it's around 200 to 300 pieces. That anything below that, it's the same amount of days.
Yeah.
Right. So that has to be priced accordingly, where anything under 300 pieces basically gets amortized the same way. With some exceptions, the per piece price only marginally increases because it's like all the setup time is just all right there.
Right.
And then as more parts get added on and on, the part price decreases, obviously, just amortizing the setup costs. Now, in terms of how the machine handles low volume versus high volume, switch over. I should be clear. Low volume for me, 10 to 25 pieces. Higher volume, I see typical orders of like 2,500 pieces to 5,000 pieces. That's pretty standard. Switchovers on this machine are not like mill turn machines because it's normal milling tools. And so you can swap those in and out and you can change tools off the machine while it's running. The only things that I have to change on the machine between jobs, one is bar size. So if I have to change the size of the bar I'm feeding, I will change 3 components on the bar feeder. It's the pusher collet, the bushing blocks, and sometimes, like if I have to change the guide channel will be switched, but that's only if I have to do something like those titanium parts that I do. It's 3/16 par, so I step it down to a really small guide channel. But normally it's just the pusher collet and the bushing blocks. And then in the machine, I change the collet in the chuck and the vise set. That's it. Everything else is same work offset, same place. I might swap out some tools, but I try to reuse tool numbers as much as possible. So it's pretty common for me that like most of the parts that I make, I've standardized on 5/8 bar. And if they're sharing all the same tools, it's very common that all I have to do is switch out the pair of jaws on the vise and I'm done.
How well do those repeat, the vise jaws?
Extremely well. So there is a pin and keyway on each side, and I cut my own jaws, so it's however accurate I can get that pin and slot fit to be, is how well they repeat. But there's also just some clever principles that you can apply to how you're holding things, so that ensures that when you put the vise jaws back on, that it's just in the right place. So things like the vise itself has programmable pressure. So when I am installing jaws and cutting jaws for the first time, I'll put it on a very low pressure and I'll grip a dowel pin and then I'll cut the jaws and then it's all in the same place, right? So then if I take off those jaws and put them back in, I'll do the same thing. I'll set the vise pressure very low. I'll put the same pin back in the same place. I'll clamp it. Then I'll tighten down all the bolts and everything is in the right place.
Gotcha.
And even centered. Yeah, I can turn the jaws around and use multiple sides and stuff like that, but it's very repeatable. So to sum up the low volume versus high volume aspect of that question, the changeovers can be very, very quick. And so I think I can switch over to any job over the course of a day, no problem. And that's what I try to keep it down to 1 changeover per day, just so I can keep the machine running.
Okay.
Yeah.
How much of your work is repeat work versus new development?
A lot of it is repeat. Oh shoot. A lot of it's repeat, but a lot of it is it's like they're all similar parts. And so they have the same features, different, just in different sizes. So for one customer, I've done somewhere between 100 and 150 different part numbers for them, but they're all very similar.
Gotcha.
Right. And so like the same interface between components, they'll be the same features for different sizes and different widths, just different dimensions.
Right. So you're not really developing a full new process. You're just kind of scaling your current process to a new part number.
Yeah. And sometimes, especially with some of the custom stuff, it's like the interface side of that component will be the same toolpaths and everything. So I could just reapply it to that. But the backside might need some special stuff where I have to rethink how I'm holding the part. So it's, in some ways, I'm still doing a lot of new parts, but in some ways I can apply everything I've been doing before. I rather like the mix, because if I was doing new stuff all the time, I would just be developing new processes all the time, right? Which is downtime on the machine. I want the machine running as much as possible. It's the only way to make this thing affordable. Both of them.
Right. So kind of to jump off the end of his question where he was talking about investments and processes that you made to streamline your workflow.
Mhm.
Let's get into deburring. What can you share, or what are you willing to share? I know that that's kind of a secret sauce with small parts, but what things have you found? What tools have you found that are really good for deburring just parts in general, and then small parts?
Yeah. So I do obviously as much as I can on the machine. My favorite chamfering tool in the machine is it's the Harvey tool 31 thou chamfer tool. And depending on what material I'm using, I'll use either uncoated or the aluminum titanium nitride coating. But yeah, just a 31 thou 90-degree chamfer tool is what I use in the machine most of the time. And that's pretty good for keeping everything like 1 to 2 thou chamfer for deburring. And then out of the machine, there's obviously still all the little corners. So where edges meet is a really common place to have a sharp edge. Hanging burrs come off of places where hanging birds like to just show up wherever they want. That's a hard one to nail down. There's a lot of stuff where it's like I'll make a part, like I'll program everything, and I'll have an idea in my head on how everything's going to go, but then there's the one alfalfa sticking out of the side of the part or something. So for that type of stuff, I have a magnetic pin spinner.
Oh, cool. Okay.
That I've gone through evaluations on a couple of different deburring methods for bulk deburring, like harperizing, which is just it's the high energy tumblers that you see from like mass finishing, stuff like that. And I've just looked at a couple of different ways of doing things, right? The vibratory tumblers and all that stuff, but the magnetic pin spinner is the only one that I've experienced so far where I can deburr the parts that the way I want to, but maintain fidelity in the features that I am measuring. Specifically stuff like I said earlier, I have a 4 thou plus or minus 1 chamfer, and I've sent that out for sampling on different deburring systems, and they'll come back just fully filleted, rounded off.
Right.
Like you look under, I have a MicroView optical measuring system, and you can see when you put it under, the chamfer's gone. It's just a fillet, which is not acceptable. It has to be a chamfer that I can measure. So pin deburring, with the size pins that I've found and the time and the amount of pins and the amount of water and all the things that that's the part that I won't share, because I feel like that's I've spent a lot of time developing that. But pin deburring by far is the one that gives, in my opinion, the best finish and the most fidelity.
Okay.
The finish itself, like from harperizing, you get the mirror finish that you see on like surgical implants. But with pin deburring, you don't get that super like 1-digit RA finish. What you get is this micro peen finish, almost like bead blasting, but it's still shiny. And it doesn't really show up until you look at it under a microscope, and it just looks like you've taken a really tiny ball peen hammer and evenly distributed that across the whole surface. And
Interesting.
it still doesn't change the RA. So you put the parts through, you measure it again, still the same RA, but it has this kind of shiny matte finish, if that makes any sense at all.
Kind of like a micro shot peen finish
Exactly.
almost.
When you feel the parts in your hand, it's a little tough to see, but they feel soft. It's a really neat feeling. If you ever find yourself in the area, I'll show you my my magnetic pin spinner.
Okay, I'll have to come by for sure.
Yeah.
What about any manual deburring tools that you use? Like, if you forget an edge on one part or the 3,000 parts, what are you using to deburr that edge?
I have the normal like 3-prong deburring tool that I'll scrape across an edge.
Are you doing that under a microscope?
Yes, I do all of this stuff under a microscope. Yeah.
Okay.
I will say that if I do find that stuff and I have to do it manually, I deburr the stuff manually before I put it through the spinner.
Okay.
Here's the thing about the spinner. It does not cut. It only rubs. So if there is a burr that you have to cut to remove, it will not remove those. Right? But if you have like hanging burrs or like little fuzz or like the burrs on chamfers, that stuff totally will get removed. But if you have a burr that has to be cut to be removed, the spinner won't remove that.
Okay.
Which if it's a burr that big, then I messed up anyway. And it should be done in the machine. The other like sacrilegious thing that I do is I have a set of pins, like inspection pins, that I set aside for only picking. And so it's, I have found, for whatever reason, that it is really advantageous to be like, I need a 65 thou pin to do this thing so I can reach in this nook and grab it with the edge of that pin. Right?
Interesting.
I feel almost dirty saying it. It's like I'm admitting it. But yeah, I have a set of pins just for deburring because it's like, man, it's like I need a really specific size pin to fit in this specific place, and the length is long enough that it does it right, and the edge, when you scrape across it just like does it nicely.
I like that. I think we all do, some sacrilegious things. We have surface plates for lapping, or like I pulled an Alton and cut off a Deltronic pin the other day because I needed a perfect fixture pin. And it's like, you do it and you're like, this feels so dirty, but at the same time, what else am I going to do? This is it.
So to be clear, I have my nice set of inspection pins, but then I have my separate set of dirty pins that I do for stuff like, I'll pick out a size if I need to deburr something really specific, or it's the set of pins that I use in the machine if I need to clamp onto a vise or something like that.
Oh, okay.
That's the set of pins that I use, and they're reference only.
Mm-hmm. Yeah. Oh, I'm sure they are at this point.
Yeah.
Let's see. Murph's Machine asks, what's the most difficult thing about setting up the UR robot? How do the 3D printed grippers work? And would you do anything differently knowing what you know now?
The UR robot that I've got is my first experience programming a robot. So the most difficult thing about programming a UR robot is knowing how to, like what do you do? Because I've seen lots of demos where someone will be like, oh, you just move the robot here and you teach that position, you teach that position, teach that position. But a lot of the stuff that I was doing was like, well, what if I want to move exactly 3 inches this way? And there wasn't a whole lot of stuff surrounding that. I will give them credit, though. If you just want to teach a couple of positions and move it to where you want it to go, totally easy. Super easy, in fact. A lot of the stuff that I've been doing, and I don't remember if it's actually on my Instagram feed. Maybe I posted it as a story, but I have 3D printed a bunch of stuff where it's like I'll have a set of arranged trays and a re-gripping fixture, and I'll go in with the robot and I'll grab the part out of the vise, I'll put it in a fixture, and then I'll turn around to re-grip it and then put it in a very specific place on the tray that's printed with little areas for the part to fall into and stuff. It's a mix of just like, oh yeah, I just need the robot to like fit in the door here as it goes through positions. But there's other ones where it's like, no, I need it to go exactly this distance away from this thing here. So I will say that was the most difficult aspect of Polyscope, which is the programming interface on a UR robot. was finding out how to do that.
That's really interesting too, because like, you know, a normal Fanic or something, that's the only way to teach it is like go exactly 3 inches this way. And so it's funny that like in simplifying it, they made it harder for your application.
Right. Now, once I found the menus and how to do all this stuff, I was like, oh yeah, that's no problem. But it's not the one that's given to you first.
Right.
3D printed grippers. They work great actually. I just use solid fill so that, you know, it doesn't like buckle on itself when you grab parts. But the Robotique end effector that I have has like programmable force. So I can program it to use a certain amount of force so that it's not bending everything. What I have found is that most of the time the stock just aluminum grippers work fine. But if I'm trying to be very careful, or it's like if it's something round and I can't grip it with those grippers, then I will 3D print something. Yeah, it works fine. You just have to use something that's like solid fill or otherwise stable. What would I do differently?
Did you say what filament you were using? I'm sorry.
Just PLA.
Okay.
Yeah.
And that holds up to both oil and 290 decent, or I guess it's only one of the machines. Is it the oil machine or the 290 machine?
Yeah. With the oil, it's been fine with the oil. I haven't tried it obviously I'm probably never going to try the machine with the 290 because there's no robot.
Right.
By the way, the robot is like integrated into the machine. It's not coming off.
Yeah. Those frames looked. I thought they were factory until I talked to Jim, and then he was like, "Oh no, we have those," and I was like, "Oh, okay."
Yeah. The final part of that question: would I do anything differently? Not really. It's kind of it's a ongoing learning experience, and I kind of use it as I need it. Here's the funny thing. Sometimes when that vise opens, there's so much surface tension in the oil that the part doesn't just fall. And so sometimes I do simple things where it's like, man, if I was just standing here, I'd like poke it and just have it go down there, right? Okay, well, I've got a robot, so I'll just open the robot door and I'll poke it with the robot just so it goes down. You know, the most expensive poker in the world.
Right. Hey, but if you got it, I mean, it was already on the machine. You might as well, right?
Yep. And that's what I had mentioned about, like, sometimes when I need the robot, it's the only way to do it. I could put a tool in the spindle that can go down and poke the part down, right? But sometimes it's just like, okay, well, the robot's there. Just use the robot.
I like that. SS CAD-CAM asked, when was your favorite White Castle experience? I'm sure there's a story behind this.
Yeah. So a couple of years ago when we went to AU in Las Vegas, Amish and I had a bro date, and we went to White Castle in the wee hours of the morning. It was the first time I had a White Castle, and he was like, "What?" Mind blown. So he said, "Okay, well, we got to go to White Castle." So if I had to pick one, it's that one.
Okay. Yeah, my business partner and I did that last IMTS, or I guess 2018. We were like, the White Castle was on the way back to the train, and we were like, "Oh well, we've never been. We might as well go." It was like,
yeah,
okay. I don't know if I'm gonna miss this, but I've had it now. Dave Precise asked, "What comes after the Willemins?"
The more Willemins, obviously.
You know, I said that to him in DM, and he was like, "No, there has to be another answer." I was like, "I don't think there is. I'm pretty sure Willemin is the answer."
Yeah. You know, early on, I was mentioning I came across Willemin. There were some other brands that I looked at. And I guess I'll mention them for the benefit of everyone else, but it's like there was the Willemin series of 400 and 500 machines. There's also the Sterag Bumotech 181 and 191, which are basically direct competitors.
Yeah, the Sterag booth had an awesome demo this year on the 191 Neo. I was really blown away and really liked that machine.
Yeah, it's very similar but different.
Right.
I would say the 191 is meant to compete with the 508.
Mm-hmm.
The 181 competes with the 408, obviously. They're kind of similar in configuration where they have a sub spindle, the 191 and the 508, and the 408 and the 181 having a vise. They just go about it in slightly different ways. The reason I ended up with the Willemin in the end was remember what you said about simplicity. Um, it's it was just a little bit more elegant. Where in the 181, the part would need to be extracted from the vise because it doesn't flip 90; it rotates 180. And that's
Oh,
how it gets
interesting.
it six-sided. And so the 181 in particular has the same articulating B-axis head, has the same vise. But when you finish a part on the vise, you have two options for back work. It can get moved down, and then you have live tools just under the main spindle, which would do the back work,
Oh, interesting.
right? And the vise itself also it just rotates, and so you could do back 5-axis work with the main spindle. But because the vise doesn't tilt down 90 degrees, the part can't fall out, and so you have to extract it.
Oh, interesting.
For the parts that I'm doing, the extraction step, if I don't need to, is wasted time. And then I would also have to have like an end effector for every part that I do.
Right.
Whereas in the Williman, if I'm doing a family of parts that only change in length, I can do them all from one. I don't even have to change the vise. I just change the program and run, and it'll fall straight down the vise into the chute.
Okay.
So I think there was one more. I think Sharon makes some machines like the FC12 and FC8. But again, they're just different.
Yeah,
Very
it's
similar.
really it's interesting seeing how all these companies arrive at kind of the same answer but very differently. It's like
Yeah.
everybody's copying each other's homework, but it's like just enough that nobody's going to get bad marks.
Yeah, they're all priced quite similarly too.
I bet. Yeah.
Yeah.
Well, that brings us on to shop news and new things. Is there anything new in your world that you can share or that you haven't shared on Instagram or anything?
Well, the newest thing was the arrival of my second Williman 408 MT. Like I said, the first one was a miracle. The second one is being struck by lightning. The implementation of the first was so successful that we needed a second one. So I've got room for a third. We'll see what happens.
Okay. Yeah, it was really cool watching your stories and then seeing everything offloaded and set up, and I appreciate you taking us along on the journey with that.
Yeah. That crate it got air freighted.
Really?
Yeah. I saw the bill for the air freight. Man, that was nuts. Someone could buy a whole machine for that.
Oof.
Yeah.
That's rough.
And then the pallet that it came on was like somebody went to a forest and took out, a whole bunch of timber from somewhere in Switzerland to build that pallet.
So was this a new build for you, or was this another demo machine, or how did that all work?
This one was a new build. They generally have allocated slots like consistently going. And then it's like a customer will come and match an allocation and then they'll get that machine, right? It's a little bit better than build to order. But sometimes it just depends on how it works out, right? If you order something and there's not a current allocation in the queue, yeah, they'll have to start one up for you. But if you match one that's in the queue and it's available, then you'll get it. So this one took 9 months to build.
Oh, wow.
Yeah.
Speaking of, go for it.
And then the other, is there a new thing? Shoot. I guess I'm just caught up in like everything feels like like everyone lives a day at a time or a week at a time. This feels like a whole month at a time.
For sure.
Yeah.
What do you think of the 408 MTS that was at the show? That thing was kind of cool with the little sub milling spindle on the bottom.
Yeah. At first when I first heard about it, a dual spindle machine, I was very excited. And I was like, oh man, that could literally cut cycle times in half for a lot of stuff. It doesn't apply to what I'm doing because a lot of the parts that I do are a lot of A-axis featured parts. And the way the 408 MTS is set up is the sub spindle is for doing back work.
Right.
And so you could only take advantage of the second spindle if you do parts that have a lot of front and back features as opposed to wrapped A-axis features. So in my case, it nets me nothing new. So
Okay.
it's not. But that said, like for the right part and the right application, literally cuts time in half.
Yeah, it was super cool, and I love they're almost like magazines of tools that you can use for the backworking one. Like he pulled it out at one point, was just checking tools, and it's like a little fan of like, whatever it was, 8 tools or whatever. And he was like, oh yeah, you could just like plop them in, oh, changing job, sure, here's another fan of tools, done.
Yep. Yeah, that was pretty neat. There is something to be said about like the magazine exchange style of tool changer, like on the Kern, for example. The Williman, you can, thankfully, you can open the tool changing door while the machine's running, right? That's really nice. But yeah, you have to pull them in or pull them out, put them in one at a time, which is fine. It's actually pretty easy. They streamline it. If you've never operated a Williman, it's another one of those things where they just like got everything right. Like every little thing is just like, oh, that's really nice. Oh, that's really nice. Oh, they thought that through. For example, when I'm loading tools, if I take a tool, I go to the tool input page, I input all the information that I want and the tool length, I hit input. And when I hit input, the tool carousel presents the pocket. I put the tool in the pocket and that tool is automatically flagged for touch off. And then there's an M code and you just put in that M code and it will touch off all tools requiring touch off, right? Like every tool has a status.
Oh, cool.
So like one example would be like if you've heard Grimsmo talk about his tool touch off process where he types in 999 for every tool and does all these other things. That's just kind of part of the experience of using a Williman control is like all this stuff is just in there. And so I won't say you can't mess it up, but it is really hard to mess up not touching off a tool. Because all you do is you just leave the tool touch off code at the beginning of a program. And if you load up all your tools and hit cycle start, but forget to touch off your tools, the first thing the program does is touch off all your tools.
That's awesome. Well, I imagine if you're running actively and you need to replace a tool that has end of life, you could just throw it in there while it's running. And, next time it calls it up, it's going to touch it off and all that.
Yep, precisely.
That's awesome.
Yeah.
That's really, really nice. Well, that brings me to the last question I ask every guest every week, which is, what did you research this week? And it can be anything under the sun. Doesn't need to be machining related. It's just what's been popping up in your browser.
Oh, shoot. Do I even think about anything not machining related?
I mean, it can be machining related. Yeah. Many of mine very often are, but
yeah. The one I've been thinking about lately is on the machine that I have coolant in. Because it's coolant, I have a lot of evaporation, right? Especially on these hot days, it'll be 90 outside. It gets up to about 80 in the shop. It stays lower because I have some HVAC going on in there, but I'll lose 5-10 gallons of water a day, maybe more. I have the new machine has a paper band filter, which increases the sump size from about 20 gallons to about 120 gallons.
Oh, wow. Night and day.
Yeah, a big difference, which is awesome because I don't think actually a 20-gallon tank would last long enough between 24-hour periods that I actually check on the machine. But right now I am delivering water to the machine with a hose connected to a DI tank. And so what I'm researching is how to build a water delivery system. There's the Mixitron. I was looking at stuff from thecoolguy.com, just what products he has, the Mixitron, the dosing device. I think I ended up with one of those. But I've seen different implementations that people do. Like they will plumb mixed coolant to the machine across the shop and things like that. I don't think I would ever actually want to plumb coolant. I would rather plumb DI water everywhere and then mix at the machine if necessary.
Yeah. That's kind of how I've always thought about it, because it'd be like, it's nice to have DI water everywhere more than it is coolant.
Mm-hmm. Yeah. So that's what I've been thinking about. And I've been researching what materials I need, what's compatible with DI water. It seems actually pretty simple.
It is surprising though, like that it'll like leach things. Like you don't really think about DI water being corrosive, but it kind of is.
Yeah. Well, galvanic corrosion, but yeah.
Yeah.
So I'm going to let the nerd out. So I care a lot about coolant concentration and water quality. I have a history of keeping aquariums. So I did a lot of planted tank aquariums. I had a reef, shoot. Yeah, I had a reef tank for a while too. I got rid of those when I moved back down to SoCal from the Bay Area, but it taught me a lot about maintaining water, right? Because maintaining an aquarium isn't about keeping fish. It's basically just water husbandry. And so I had an idea that I implemented on the Williman because I had the opportunity to. But you know how they say the first coolant charge, you're supposed to start with tap water so that the oil concentrate has something to adhere to and emulsify, and also not foam. Well, when you use tap water, you still get everything that's in that city water, right? So you still get the chloramines, you still get fluoride, you still get all the other chemicals associated with tap water from your city, and also like particularly high concentration of like high grain water, right? Like the water coming out of my faucets, like 550 TDS, which is hard.
Oh yeah.
And so I had my grand idea was, okay, I'm going to start with DI water, 0 TDS water, and I'm going to use one of my aquarium products called Equilibrium to reintroduce minerals back into the water. But it's because it's an aquarium product, it's controlled minerals, and so I'm reintroducing all the calcium carbonates and all the things that I need back into the water for the coolant to emulsify, but I'm not introducing anything I don't want, right? So then I could also like very specifically target, I want 100 TDS or like somewhere between 50 and 100 TDS for my first charge, emulsify the coolant, put it all in there, and then I charge with only DI water after that, right? So I did it. It worked. Great. If anybody wants to replicate that, the product is called Chem Equilibrium. It's really cheap. It's meant for like hobby aquarium people, and you only need like a couple teaspoons.
Wow.
Yeah.
Huh. I've never thought about that, but it makes total sense.
Yeah, and we'll see how it goes. It'll be an ongoing thing. But I've got in my Haas VF2, I've got 250, Qualcomm 250, and it's been in for 2-3 years, and it's still perfectly clean. But I also don't use it that often, so I still expect that I'll see really good coolant quality for a long time because I've got the paper band filter, and I've got a 25 micron canister filter in just on the machine, right? Mm-hmm. And then I'm on top of that, I am spending a lot of time on the water quality, so I expect to have good results for a while.
Oh yeah. Yeah, the Qualichem seems like it's fairly good at rejecting stuff anyway. So if you're at all on top of it, it's usually pretty decent.
Yeah, and I've also got the coalescing filters, the oil skimmers, like the next gen or see-through. Yeah. I've got 2 of those. I will put one of those on every machine that are on coolant. But
I love those. Like it's just nice to adds a couple gallons to your tank volume, and B, it's really nice to be able to see actual things getting filtered out.
Yeah.
Well, CJ, thank you so much for taking the time. It's been great. I'll have to have you back on at some point because I know we skimmed over a bunch of stuff, and I'd love to nerd out more on post development and more Williman stuff. But
absolutely,
I really, really appreciate you taking the time. It's been great to catch up and hear more about your business because I know every time we talked in the past, it was just growing, and now you're full time there.
Yeah, it was like I said, this is a long time coming, right? At the time when you first asked me, I was like, I don't know if I'm ready. Like, I don't know if I even have anything to share. Now I feel like I actually have something worth sharing, and I think give it a little bit more time, and I'll have more.
Definitely. Where can people find you one more time if they want to check you out online?
I just post to Instagram, cj.abraham, and if people are interested or requested enough, maybe I'll start posting some YouTube videos or something. I don't know.
You heard it here. Everybody go bug him because I would love to see some YouTube videos, especially on how you have set up these machines. Whatever you can share, I think would be really, really valuable.
Sure.
And thanks to all the Patreon members, new ones, Chris and Paul. You guys all make this show possible and make it so I can have people like CJ on. So thanks everyone for listening. I'll be back next week.